Expression for velocity in spherical polar coordinate. In spherical polar coordinate, you have radial distance r, you have polar angle theta, and you have azimuthal angle or angle in the xy plane phi. So when we express velocity in spherical polar coordinate, you will have three components of velocity. One is your r dot, which is in radial direction. The second one is your theta dot, which is in polar direction. And the third one is your phi dot, which is your in xy plane or in azimuthal direction. Here r dot means the derivative of r with respect to t. The theta dot means the derivative of theta with respect to t, and phi dot means derivative of phi with respect to t. And you have also three unit vectors. Either you write unit vector r theta, r cap, theta cap, phi cap, or you may write e r cap, e theta cap, e phi cap like this. I have discussed about unit vectors in the previous video. So the velocity in spherical polar coordinate will be equal to r dot e r cap plus r theta dot e theta cap plus r sin theta phi dot e phi cap. I have shown you in the previous video that r sin theta is the component of r in the xy plane, and in the xy plane you have the angle phi. So in velocity, in the expression for velocity, you have r sin theta in phi direction or xy plane. And let us derive how the velocity in spherical polar coordinate is equal to this equation. In the previous video, I have shown you the position vector in the radial direction, that is r vector is equal to magnitude of r multiplied by the unit vector e r cap. So if you take the derivative of this position vector with respect to t, then you will find out the expression for velocity. So velocity will be equal to derivative of the position vector with respect to t. So derivative of r multiplied by the unit vector e r cap with respect to t. So you differentiate it. First you differentiate, suppose e r cap, r, then dr by dr with respect to, and derivative of r with respect to t, keeping constant e r cap plus r into derivative of e r cap with respect to t. So the velocity will be equal to, what will be dr with respect to derivative of r with respect to t, you can represent it as r dot. So r dot, then e r cap, this is your e r cap, plus r into derivative of the unit vector e r cap with respect to t. In the previous video, we have explained how e r cap vector is equal to sin theta cos phi I cap plus sin theta sin phi j cap plus k cap cos theta. So you substitute e r cap is equal to this value, and you find out the derivative of e r cap with respect to t. So if you find the derivative of e r cap with respect to t, it will be equal to theta cap e theta theta dot e theta cap plus phi dot sin theta e phi cap. So now you substitute the value of the derivative of e r cap with respect to t here. Then you will get the expression for velocity v equal to your r dot e r cap. Here you write r dot e r cap, and in place of the derivative of e r cap you write this one and multiplied by r. So the value will be r multiplied by theta dot e theta cap plus phi dot sin theta e phi cap. So finally we will get the expression for velocity of a particle in spherical polar coordinate, that is v equal to r dot er cap plus r theta dot e theta cap plus r sin theta phi dot e phi cap. So velocity have three values, one value along the radial direction, another value along polar direction, and the third one along your azimuthal direction.